working out a confidence interval for the population mean. Mixed examples. In this example, we have a random sample of 8, and here are the sample values. We're looking for a 95% confidence interval. The population standard deviation, sigma, is given. It's 0.15. The population is normally distributed. So from these three options, because the population standard deviation is given, and we know the population is normally distributed, we're going to use this formula. Example 2. In this case we have 160 for the sample size. The sample mean, so x bar, is 81.3, and the sample standard deviation, S, is equal to 19.3. There is no mention that the normal distribution applies. Because the sample size is large, we can use the central limit theorem. So for the calculation of the confidence interval, this formula will be used. Because we don't know the population standard deviation, but we do know the sample standard deviation. And for a large sample, the sample standard deviation is a good estimator for the population standard deviation. So we're using the normal distribution to work out the confidence interval. From the normal tables, looking up p is equal to 0.95 gives a z value of 1.6449. So 90% is in the center with 5% in each tail. So we look up 95%. Example 3. The sample size is 8. A normal distribution applies for the population. The sample is small. No standard deviation is given for the population. So in this case, a t-distribution applies. So we're going to work out the standard deviation for this data, and we're going to use the t-distribution because there would be considerable uncertainty in the calculation of our standard deviation, because we're going to use that as an estimator for the population standard deviation. So this formula is being used. The S in this formula can be calculated either from a given sample or from this formula. And the variance version of this formula is in the formula book on page 12 here. You must remember, if you're using this formula, you divide by n-1. So this is for the variance. For the standard deviation, you would square root this. The sample mean, and the sample standard deviation. With 7 degrees of freedom, so that's n minus 1, 8 minus 1. Looking at p is equal to 0.95 from the tables. Table 5, t distribution, p equals 0.95, degrees of freedom is 7, so t is 1.895. Confidence interval. Example 4, a sample of 90, a large random sample. There's no mention of the normal distribution, so the central limit theorem can be used. So this calculation here is from page 12 in the formula book using this.